In the assignment set in Chapter 12, one of the problems you need to produce what's called a residual plot. You take the errors, the difference between the actual value and what's predicted, take those numbers and plot them against your independent variable. And you could do that with a scattergram. You could just take the data once you get the data generated and then just use the scattergram to see what the relationship is. But Excel has that as part of the tool. So what I want to do in this little video is to show you how to use the regression tool to get that residual plot. So we have the data here where we're trying to predict the mortgage based on the independent variable of rent. So we just go to the Data tab and pull up the tool. Slide down here to the regression. We're predicting the mortgage. So we just select the label and the data values. It's based on the rent, so we just select the label and the data values. Check the box for the labels. I want to put it in A13. But now I'm going to check the box for residual plots. And it'll just build that graph for me. Now let's space it out. I'm going to click on the graph and lengthen it a little bit, make it a little taller. Now when you look at the pattern of the points inside the graph, you can see this definite U-shaped. What you really would like to see is at 0 to see these points pretty much spread out evenly all the way across the range of the data. Probably what you'll see most of the time is kind of a random scattering of the data points, but you don't want to see a pattern like this. This is definitely a U-shaped, and this indicates that you don't really have linear data. The errors, you're getting positive errors followed by a bunch of negative ones, and then you go back to positive ones again. But you're getting this U-shaped. You want to see them kind of go up and down a little bit more frequently than this. So one of the things that this suggests is that you might ought to add a second order term, and that wouldn't be linear regression. But the tool that's in Excel will actually let you do this. You can just generate that square term and just use it as multiple regression. And it'll go through and figure out what the coefficients are. But this one, if you look at the p-value, it's a good model at the 0.05 level of significance. Your R-square value is about 75.6%. So this model explains 75.6% of the variability in mortgage just by using that one variable, just by using rent. This course doesn't really cover nonlinear forms or multiple forms, but let me just show you what you can do here. Now I've got all the data showing up now. But I put a square term in here. So I'm going to go back to my regression tool. It's going to remember everything I did previously. I don't want that one. I want to use this one I put over here. It's the same set of numbers, so I could have used that one. But the difference is I'm going to use the square and just the rent values themselves. Labels, let's put this one in R13. And let's see, got the output, residual plots. And we'll let it solve it using more than one predictor variable. Now let's spread it all out. Now there were two predictor variables, so it does a residual plot for each one of them. And you don't see that well-defined U-shape in here anymore. So there's not an issue with the lack of fit on this one. But what's happened is both of these variables are contributing. When you look at the p-values, they're both smaller than 0.05. So they're both making a contribution to the prediction of the mortgage values. But what it's really done for us is this R-square value has gone from about 76% up to almost 90%. It's just a better model in terms of prediction. The typical error that you expect to make. Back here when we were just using rent to do the prediction, we expected to be off almost 78 units, almost $78. When we put in the square term, our typical error, that standard error of the estimate, has gone down to about $54. But it's just a much better prediction. But with multiple linear regression, what you can do is you can add other independent variables, and you can make your error, make your typical error, make it smaller, and you can come up with a better model. But you're only responsible for the simple case. I just thought I would lead in and show you kind of the way that you can put in more than one variable and just come up with a better model.